All right, ladies and gentlemen, moving forward into exponential functions, we need to learn how to solve. So we're going to learn how to solve exponential equations, mostly algebraically, although I will mention the other way graphically. So the idea of today is to mostly look at examples because it's the best way to learn this particular concept. Because there's so many different types of examples, the ones that I show here will hopefully help you with the ones on the assignments, and hopefully I've given you enough examples. I think I have 7 or so like that. All right, so in order to solve things algebraically, you need to use inverse properties, not our log properties as the previous lesson. Our log properties are not the ones we want to be doing here. You could also do it graphically, where you would graph 2 different equations and find the intersection points. That would be or finding the zeros if you set it equal to 0. And it kind of depends on the problem, but for the most part, I think we can do all of this algebraically. The graphically is kind of a way to check your algebraic answers. All right, so describing the inverse properties are going to be best done on the examples themselves. So let's start with this particular example. I have 20 times 1/2 to the x over 3 equals 5. And what I need to do is, for solving equations, we need to figure out what that little x is. So I need to get at that x. Well, the first thing, this is an exponential equation, by the way. And this exponential equation has an exponent base 1/2 times an initial value of 20. And I want to know when this function equals 5. Now, graphically, we would graph this one as y1, the first equation is y1, and the second equation is y2, and we'd find their intersection. But I don't really want to do that. What I'm going to do is I'm going to divide both sides by 20 to get an easier statement here. So I have 1 over 2 to the power of x over 3 equals 5 over 20, which is the same thing as 1 over 4. Now, some of these particular problems, we can use a very, very simple formula or very simple, I don't even know how to say it, expression. If I told you that let's not do x, if I told you that 2 to the 3rd power is equal to 2 to the x power, you could probably tell me that x is 3. That's a very, very simple property that most of us probably already knew without ever having to define it. The reason I bring this up is because I want to solve this equation that way. So I want to change the base, basically. I want to look to see if these are the same thing. And I know in my head that 1 over 4 is the same thing as 1/2 squared. So I'm going to rewrite that as 1/2 squared. And I already had this side as base 1/2. Oops. That's supposed to be x over 3. Oh, apparently I'm going to go blue now. All right, so this tells me now I can use that property as before. This is 1/2 to the x over 3 equals 1/2 to the second, which means my exponents have to be equal. And now this is really easily solved. X is 6. There's your answer. You always kind of have to check to make sure that it's not an extraneous answer. So some of you guys don't like that word, but this particular case, I can plug in a 6 and get out a number. In this particular case, we get our answer as 6, and we are done. All right, so that's example 1 under the belt. Let's look at example 2. Example 2 says logarithm, the common log of x squared is equal to 2. Now, there are a couple right ways to do this and a couple wrong ways to do this. And I'm going to show both. I want to make sure you guys completely understand this. So this is the good way, and this is the bad way. The good way is to change this logarithmic equation into an exponential equation. Sometimes that's easier to solve. So this is log base 10. So I'm going to say it's 10 to the power of 2 equals the x squared. And this is from our properties from right at the beginning of logarithms. Well, if 10 squared equals x squared, you could technically do this if you really want to. 100 is equal to x squared, and then you square root both sides and you get x is equal to plus and minus 10. And you could verify this for yourself. If you plugged in 10 or negative 10, you would get 100, and log base 10 of 100 is 2 for both of these cases. So this is the good way to do this. The bad way, weirdly, and I've never quite figured this out either, I've asked a couple people here why this doesn't work. Using one of our properties as before, our power property says I can bring down the 2, and I get log of x is equal to 2. I can divide both sides by 2, and I get log x equals 1. And our property says that that means x equals 10. Now, some of you are like, well, that's the answer I got from before, but it's not. Notice it's only half of the answer you got before. We only got the positive 10 where it should have been positive 10 and negative 10. And don't just think, oh, I'll just add the negative as well. It doesn't work that way. You can't just hope for the best by adding the positive and the negative version. Okay, so don't do this way. I just showed it so you wouldn't do it ever again. This is bad, ugly. Don't do it. Okay, yuck. Do these properties here. You don't always get to use the properties from before. We will use some of them, but not this one. We can't use this one in this manner. Okay. Number 3. 0.98 to the x power equals 1.6. Now, like the very first problem, I just changed the bases. But the problem is I don't even know how to change 1.6 into 0.98. So what I'm going to do here is one of our things like we've always done, if we do something to one side, we can do it to the other side. Well, just like we square both sides or square root both sides, we can actually take the logarithm of both sides. I'll also kind of show you two different methods here. They're basically the same thing. So I can take the logarithm of both sides. And it doesn't matter what logarithm you take. This particular case, I did logarithm base 10. Now I know I just got done saying I can't do this, but it doesn't matter. In this particular case, because the x is my exponent, it doesn't eliminate answers. I'm going to use my property. I'm going to bring down the x. And you'll see later on, I'm going to do this a little bit differently. This is actually how we're going to do it. We're going to bring down the x. We're going to say it's log of 0.98 equals the log of 1.6. And this is x times a number, which means I can divide both sides by that number. And that whole fraction is a number. Notice I just got x by itself and I didn't even mention it. And if you do this on your calculator, log of 1.6 divided by log of 0.98, we get x is equal to approximately negative 23.26. Let's go 264 just for the heck of it. And you could always take this and plug this back up into here to check to make sure you got the right answer. And 0.98, if you just hit caret answer, you'll get 1.6. All right? So that's kind of the one method. I want to actually kind of think about a different method here. It's basically the same thing though. I don't want to just take any logarithm of both sides. I want to be able to cancel out this 0.98. Well, in order to cancel out exponential base 0.98, I need to take the logarithm. I can take the logarithm of base 0.98 of 0.98 to the x power equals the logarithm base 0.98 of 1.6. Well, this piece on the left cancels and leaves me with an x. And notice I automatically have my answer. Well, what's nice is this. You could technically plug this into calculator just like this, or you get, with the change of base formula, log of 1.6 divided by log of 0.98, which again is approximately negative 23.264. So notice it's basically exactly the same thing, but I didn't have to think about that property of bringing the x down in front. Okay, this is actually the kind of one that I want to think about mostly when I look at exponential problems like this, though. I want to take the logarithm, a very specific logarithm of both sides, not just a random log base 10 or natural log. All right, example, what is this? Number 4 now. Example number 4, 3 minus the logarithm of x plus 2 is equal to 5. So I have to get the logarithm by itself, so I have 3 minus, so I'm going to subtract 3 from both sides. I get the negative logarithm of x plus 2 is equal to 2. I have to get rid of the negative just because it doesn't really help me at all right now. Log of x plus 2 equals negative 2. Well, because this is a logarithmic equation, I like to just change it back into exponential. So this is log base 10. So it becomes 10 to the negative 2 power is equal to the thing inside the logarithm, x plus 2. Well, that's nice because 10 to the negative 2 is actually 1 over 100. And I'm going to subtract 2 from both sides. So I get x is equal to negative 1.0, 1/10. So I'm going to take 99, huh? Sorry, 1/100ths. Okay. Do a quick double check. Remember, you cannot take the logarithm of a negative number, but negative 1.99 plus 2 is positive. Okay. So that's positive, and that means it's all doable, and you'll figure out if you plug that in, that answer will come out correct. Number 5, told you. If you notice the top of the line, thing says examples galore. Means a lot, if you didn't know that. Okay, this is almost exactly the same as the last problem, only in this case, it is an exponential problem, or an exponential equation, not a logarithmic equation. So I have to do the same thing. I have to subtract 7 from both sides. Then I have to divide by negative 3. And then I have to figure out how to get rid of e. Well, this is just an exponential problem base e, so I get to use my logarithm base e to cancel. So I'm going to take the logarithm of both sides. And this tells me those cancel, so I can say it's negative x is equal to the natural log of 5/3, which means x itself is equal to negative natural log of 5/3, which is approximately, if you have your calculator in front of you, if you don't, I'll go ahead and do it here. Negative natural log of 5 divided by 3 is negative 0.511. And you could always check this really quick, plug that in. Since it's an exponential function, my domain is all real numbers, so it's not a domain restriction. You just got to make sure that you get the right answer. And if I did that really quick, 7 minus 3 times e to the answer, to the negative answer, is 2. Good, that means I got the right answer. Phew, I never know sometimes. All right, I've lost track. I think that's number 5. So 8 times the natural log of x plus 2 to the 5th equals 5. I would not, do not do this. Do not go ln of x plus 2 to the 8th power, because you don't want to have to deal with x plus 2 to the 8th power. But what I am going to do is I'm going to divide by 8 on both sides. I'm going to get the natural log of x plus 2 equals 5 over 8. And then, since it's a logarithmic equation, I'm going to change it back into exponential. So this is base e. So it's e to the power of 5 over 8 is equal to x plus 2. I really, really hope you guys are getting fast at changing between logarithms and exponentials. If you're not, just keep practicing. Now, e to the 5/8 is just a number, so I'm solving for x here, so I can subtract 2. So x equals e to the 5/8 minus 2 on the outside. Don't put that in the exponent because that's not where it belongs. So x is approximately, let's go e to the 5/8. Subtract 2. I get negative 0.132. Always do a double check. Make sure. If you're confused when I keep saying just plug in a and s on your calculator, it's down above the negative sign. It's a very handy thing to do if you don't know how to, if you've never used it before. You can just do 8 times the natural log of a and s plus 2 and see if that comes out to 5, and sure enough it does. All right, so here comes some challenging ones. This one gets an asterisk because I think it's a challenging problem. You just have to kind of you get to use a property here. So you get to use some properties. First property saying, let's combine these two natural logs. So this becomes the natural log of 3x minus 2 times x minus 1. And I'm also going to put the power property here on the right-hand side. So this becomes the natural log of x squared. Now, when I do this, this might end up with some extraneous answers later on. So here I get the natural log of 3x squared minus 5x plus 2, I just FOILed, equals the natural log of x squared. Well, in this particular case, since I have the natural log of something equals the natural log of something else, that means those somethings have to be equal, which means I'm just going to get 3x squared minus 5x plus 2 equals x squared. So I'm going to subtract x squared from both sides. I get 2x squared minus 5x plus 2 equals 0. I really hope this factors to make my life a little bit easier. So let's try 2x and x. And since it's a plus 2 and a minus 5, I really hope for both minuses. And I think this works right here. A minus 4 and a minus 1 makes a minus 5. Oh, good. That means it's factorable. All right, so x equals, for this one, I get 1/2. And for this one, I get x equals 2. Now, here's where the issue comes in. Do both of them work? Do any of them work, or do just one of them work? So I take these numbers and I do a quick check into all of the x's. Now, because neither of these are negative, it's okay for the right-hand side. However, if I plug in x equals 1/2 into either of these two pieces, the two pieces on the left, those both come out negative, and I can't do that, which means that is a non-answer. That's extra. Oops, let's spell it right. Extra or extraneous. If I plug in 2, well, 2 is okay here. That makes it positive. 2 is okay here. That makes it 1. That makes it positive. 2 is okay here. So plug in x equals 2. Make sure you get the correct answer here all the way across. All right, so that was a 1-star problem. Let's try a 2-star problem. This one is super challenging. This one might require me to erase the whole screen once just to get the last part of the problem on here. This is our last example, by the way. All right, so e to the x minus e to the negative x over 2 equals 5. Well, I want to get the e's by themselves, so I'm going to multiply both sides by 2. And I get 10. Now, some of you guys are probably going, I don't know what the heck to do here. But here's what we're going to do. We're going to look at this as e to the x minus 1 over e to the x equals 10, changing this negative exponent into a positive exponent. Well, this means I now have fractions that I can combine. So I'm going to multiply this by e to the x and e to the x. Now, I know this isn't always how I did this. I guess normally I would multiply by e to the x everywhere, and let's just go ahead and do that because that's actually kind of how I normally do this, huh? So let's go and multiply by e to the x everywhere, and I get e to the 2x, because you add exponents here, minus 1 equals 10 e to the x. Now, this is where it gets a little bit weird. If you look at this equation, it doesn't look like it's very solvable algebraically. However, it actually is. This equation actually kind of looks like something squared. Well, it actually is. It's e to the x squared minus 10 somethings minus 1. And guess what? Most of those somethings are the same. They're both e to the x. E to the 2x, e to the power of 2x is equal to e to the x squared. Well, that means this is a basic quadratic. Now, it's not factorable, but you can use the quadratic formula. So I can say w equals the opposite of b plus or minus the square root of b squared minus 4ac all over 2a. This one's challenging, because we're not even done yet. We're not even as close as you might think that we are. You might think, oh, as soon as we do this quadratic formula, we're done. The problem is we're not. Okay, so this is 10 plus or minus the square root of 104 all over 2, which is approximately 10 plus square root 104 divided by 2. We get, let's say, w is equal to 10.099, and w is equal to, if you do this really quick, you might beat me to it, negative 0.099. Those are not your answers, because this is what w is. But we let w equal e to the x. That means e to the x is equal to 10.099, and e to the x is equal to negative 0.99. 0.99, geez Louise, mister. So now I have to solve these little exponential problems. That means I have to take the natural log of both sides. And I get, if I take the natural log, I'm not going to write that out, but if I take the natural log of both sides, I get x equals the natural log of 10.099. And here I get x is equal to the natural log of negative 0.099. But the problem is I can't do the second one there. I can't take the natural log of negative numbers. Well, that's kind of nice for me because that eliminates half my answer. So if I do this, I get the natural log of 10.099. And I get x is approximately equal to 2.312. And ta-da. Look, I made it through without even having to erase. So sometimes we get these little quadratic type problems where you have to exchange an exponential for a variable and then solve using quadratic formula and then re-exchange it back to an exponential and then solve the exponential equation. Kind of complex, but still doable. You guys are all smart enough, all bright enough to do it. And I wish you the best of luck on this. So you guys have your assignment sheet. For question 49, you're going to jump to page 326. And you are going to follow example 7 using Newton's law of cooling. I want to see how well you guys can follow an example in order to find a solution for yourself. All right? Have a good time doing math. I will see you guys in the morning.